5 unit 4. Here we are going to take how the agent will take the decisions in the uncertain environment so that the agent will be able to take whatever it wants. Okay. So how the agents are taking the decisions, that is the main topic here, students. Okay. So here in this particular chapter we are going to discuss the decision theoristic agent. This is the agent. It is going to take the decisions in the um, uncertain, and whenever there is a conflicting goals, okay, this agent will be able to take the decisions properly. Okay, so this decision theoristic agent will be based on utility theory and probability theory. Okay, these two theories are combined. So based on these two theories, this agent will be able to take the decisions. Okay, so, and this agent will be taking the decisions, rational decisions, means which will give you the 100% result. Okay, rational decisions based on whatever knowledge it has and whatever goal it has to reach. Okay, based on these two, this decision theoristic agent will be able to take the rational decisions. Rational decisions means that the decisions will give us the 100% result. Okay, and here this decision theoristic agent, I told you, it is able to take the decisions in uncertain and conflicting goals. Okay, so whereas logic agent, if you take this logic agent, will get confused whenever there are conflicting goals. It will confuse that which decision to take. Okay, so sometimes it will not take any decisions. Okay, so that is the, because logic agent depends only on some laws. Okay, if that particular law is not satisfied, what it will not take any decisions. It will get confused. Okay, whereas this decision theoristic agent will be able to take the decisions if the environment is uncertain and if it is having conflicting goals also. Okay, so here, if you see this goal-based agent, the goal-based agent will be having the binary distinction between the goal state and non-goal state. Whenever it is reaching the goal state, it will give the value 1. Whenever it is reaching non-goal state, it will give the value -1. So what is this goal-based agent? So it has to reach the goal state. So to reach the goal state means it has to achieve the value +1. Okay. So it is that so that whenever it is not goal state, it is given with -1, so that it will not. So when there is a -1, means that it will take some operations. Finally, it will reach the value +1. Okay. Now, how this decision heuristic agent will be? The decision heuristic agent will continuously measure the different states. Okay. So whenever some action is performed, what happens? So the environment will be changing from one state to other state. Okay. So what is this decision heuristic agent will do? This decision heuristic agent will continuously measure each and every state, so that, okay, so based on that, it will be taking the actions and finally it will be reaching the goal state. Okay. So before discussing how it is taking decisions here, first we will be discussing what are the beliefs and desires and the uncertainty. Okay. So what are the uncertainty beliefs and desires we are going to discuss. So here we'll be having different state. Whenever action is performed, we have discussed that we are getting different states. Okay. So the agent should take the preference between these states. Okay. So which state to be considered? For example, you have multiple options. So you have different. Your parent has given option to select any one of the folds. So they have given 3 options. Okay, based on that, you need to select any one. So you'll be having some preferences or not. So to have the preference here, what is that here the agent will be doing? The preference will be taken based on utility function. So what is utility function here is, the utility function is that it will assign some value to each and every state. Okay. So for example, there are 3 states. The agent has to take any one, consider any one of the state. Okay. How it will consider any one of the state? There is some value assigned to each and every state. Okay, based on that value, whichever state is having maximum value, that value will be taken, will be considered. Okay, so the what is that utility function here? Assigning some value to each and every state is called utility function. Okay, now what is that? Instead of having only function, what is that here is done is utility function is combined with the outcome probability. For every state, there is a probability of outcome. Okay, so for example, you have a particular state. What is the probability of getting state is given like this. Okay. So what is the probability of getting S1 is 0.2. What is the probability of getting S2 is 0.7. Probability of getting S3 is 0.1. Okay. Like that, every state is having some outcome. So what is that here we are going to do here is we are combining utilities with the outcome probabilities. Okay. So that getting expected utility for each action. Okay. So if any action is performed, say A1, action A1 is performed, what is the expected utility for? It's not by performing A1. We are combining the utility with probability. So 100 into 0.2, 50 into 0.7, 70 into 0.1. That gives you what? The expected utility for this action. Okay, if that particular action is performed, what is the expected utility? Like that, we will be finding what is the expected utility for each and every action. Okay, so here we are using the notation U of S. So U of S is the notation is used to denote what is the utility of particular state according to the agent that is making the decisions. Okay. So what is the utility for the state S naught for action A1 is denoted as U of S naught. Okay. Similarly, for any state S, okay, what is the utility for the agent to take the action, to take the decision is U of S. U of S indicates what is the utility of state S according to what is the what that that is that the agent is taking the decisions. Okay. So here, what is that? Whenever some actions are performing, what happens? We are getting different states. The environment we are getting different states. Okay. So the states are nothing but what? The complete snapshot of the environment. How the environment is changing. Okay. Whenever we want to get shoot a video, what is that we will be getting? We will be getting snapshot of some pictures. Okay. So like that, the complete state, what are the different states the environment is getting by performing different actions is nothing but the complete snapshot of the environment. Okay. So if a non-deterministic action is performed on the environment, what happens? We will be getting different states. See here, if an action A1 is performed, what is that here? We are getting different states. Yes or no? Similarly, if any non-deterministic action means you cannot predict what are the outcomes. Okay. So by performing this action, what are the outcomes we will be getting that we cannot predict. Okay. So that action is called non-deterministic action A. So if non-deterministic action A is performed, what are the different possible outcomes? What are the possible outcomes here we are getting that we are denoting as result I of A. Okay, so these are the possible outcomes. So result 1, result 2, like that, these are the possible outcomes. Okay, so what is I here? I is the range of different outcomes. If particular action is performed, what is the range of different outcomes? So here action A1 is performed. What are the outcomes here? S1, S2, S3 are the outcomes like that. So if action A is performed, what are the different outcomes that will be denoted as result I of A, where I is the different outcomes. Okay. Now before executing A, what is that agent has to do? The agent has to calculate, assign the probability for outcome of every state. So the probability of result I of A by performing the action and the given evidences. Okay. So this probability should be assigned to each and every state. Okay. So what is do of A here is the action A. The action A is performed on current state. So where E is the available evidences. Okay. And what is the probability of outcome by performing action for with the given evidences? This value should be assigned to each and every outcome before the execution of B. So the expected utility of action given the evidences, this we have discussed. What is expected utility of action given the evidences is calculated by what? We need to combine the probability with the utility. Okay. So that's what we discussed. No, here combine the probability. What is the probability here? 0.2 and the utility value is 100. Okay, 0.2 into 100, 0.7 into 50, 0.1 into 70. Okay, so like that probability will be
Ma'am, your voice disturb అవుతుంది మ్యామ్.